exam, you might be given a number that has already been rounded and asked to give a range of possible values for this number. The largest possible value for the number is known as the upper bound, and the lowest possible value for the number is known as the lower bound. To find the lower bound of a number, you first need to find out what the number has been rounded to. Once you know that, you can work out the smallest value the number could be. You can also use the same information to find the largest possible value for the number. Let's look at an example. The length of a line is 14 centimeters, corrected the nearest centimeter. Find the smallest and largest possible length for the line. Since the number has been rounded to the nearest centimeter, we know the actual length could be up to half a centimeter smaller or larger than 14 centimeters. The smallest value that could still round up to 14 centimeters is 13.5 centimeters. Anything smaller than that would round down to 13 centimeters. The largest value that rounds down to 14 centimeters is just under 14.5 centimeters. Now instead of writing a long string, we simplify it to 14.5 centimeters. So, the smallest and largest possible lengths for the line rounded to the nearest centimeter are 13.5 centimeters and 14.5 centimeters. Note that the number won't always be correct to the nearest whole number, like in this example. Sometimes it'll be correct to a number of decimal places, or to the nearest 10, 100 or 1000. The general rule is to halve the value of the digit it has been rounded to. The lower bound is found by subtracting this halved value from the rounded number, and the upper bound is found by adding it. For example, if the number 6,200 is rounded to the nearest 100, you need to halve 100 to get 50. To find the lower bound, subtract 50 from 6,200 to get an answer of 6,150. To find the upper bound, add 50 to 6,200 to get an answer of 6,250. So the smallest possible value of the number that has been rounded to the nearest 100 to get 6,200 is 6,150, and the largest possible value is 6,250. Here are a few for you to try. Press pause and have a go. Once you're ready to see the answers, press play. Bounds can also be represented with error intervals. An error interval is a way of showing the range of possible values a number could have been before it was rounded. Here's an example of an error interval. The number on the left, in this case the 14.5, represents the lower bound, and the number on the right, in this case the 15.5, represents the upper bound. For this example, the error interval shows that the number is greater than or equal to 14.5, but less than 15.5. To practice writing upper and lower bounds as error intervals, here are a few exam-style questions for you to try. Press pause and have a go. Once you've finished, press play to see the answers. When performing calculations with numbers that have been rounded, you might be asked to find the upper and lower bounds for the answer. Here are the rules you need to know. If you need to find the upper and lower bounds when adding two numbers, just remember that two upper bounds added together make the upper bound, and two lower bounds added together make the lower bound. If you're subtracting, remember that the upper bound minus the lower bound makes the upper bound, and the lower bound minus the upper bound makes the lower bound. For multiplication, it's very similar to addition. Two upper bounds multiplied together make the upper bound, and two lower bounds multiplied together make the lower bound. Division is often the hardest one to remember, but it follows a similar pattern to subtraction. The upper bound divided by the lower bound makes the upper bound, and the lower bound divided by the upper bound makes the lower bound. This is because when you divide the smallest possible value of one number by the biggest possible value of the other number, you get the lowest possible result. Here's an example GCSE-style question. When you're ready for me to go through the answer, press play. To find the lower and upper bounds for the perimeter, start by finding the bounds for the length. Since the length is rounded to the nearest 0.1 meter, the lower bound is 8.35 and the upper bound is 8.45. Next, find the lower and upper bounds for the width. Since the width is also rounded to the nearest 0.1 meter, the lower bound is 5.15 and the upper bound is 5.25. Finally, to find the lower bound for the perimeter, add the lower bound of the width to the lower bound of the length and double the answer. 8.35 plus 5.15 equals 13.5, and 13.5 times 2 equals 27. To find the upper bound for the perimeter, add the upper bound of the width to the upper bound of the length and double the answer. 8.45 plus 5.25 equals 13.7, and 13.7 times 2 equals 27.4. So the final answer for the lower and upper bounds of the perimeter is 27 and 27.4. Now we can move on to finding the lower and upper bounds for the area. To find the lower bound, multiply the lower bound of the length by the lower bound of the width. 8.35 times 5.15 equals 43.0025. To find the upper bound, multiply the upper bound of the length by the upper bound of the width. 8.45 times 5.25 equals 44.3625. So the final answer for the lower and upper bounds of the area is 43.0025 and 44.3625. If you have any questions, just write them down in the comments section and I'll try to answer them as quickly as possible. Thanks for watching and I'll see you next time.